Think about the night sky as a permanent, unmoving ceiling. Now, imagine that every star you see is actually part of a massive, glowing island of fire hurtling through the dark at 250,000 miles per hour. You click because you want to know what happens when our home, the Milky Way, finally slams into its neighbor, Andromeda. Sounds like science fiction. In fact, this is the brutal reality of galactic evolution. A slow-motion car crash on a scale so large it defies human logic. While we feel safe, the countdown to the greatest collision in history has already begun. Where are you watching from today? Tell me below. Let's map the end of the sky. To understand this collision, we have to look at the Andromeda Galaxy, M31. NASA's Hubble Space Telescope has spent years tracking this massive spiral, which sits about 2.5 million light-years away. For decades, astronomers knew it was moving toward us, but they didn't know if it would be a direct hit or a near miss. In 2012, NASA scientists used Hubble's precision to confirm that Andromeda is coming straight for us. This is the first major mechanism, the gravitational pull. Because galaxies are the heaviest things in the universe, they act like giant magnets. Even though the universe is expanding and pushing most galaxies away from each other, the Milky Way and Andromeda are gravitationally bound. They are part of the local group. Consequently, they are falling toward each other in a dance that has been going on for billions of years. The second best point to establish here is the relative speed. Andromeda is closing the gap at 68 miles per second. That is fast enough to travel from Earth to the Moon in about an hour. However, space is so vast that even at this breakneck speed, the collision won't actually start for another 4 billion years. NASA's Gaia mission, which maps the positions of stars with extreme accuracy, has added a twist to this timeline. It's not just the Milky Way and Andromeda. The Triangulum Galaxy, M33, is also part of this pileup. It might hit Andromeda first, or it might get caught in the crossfire. Imagine a three-way intersection where the cars take billions of years to reach the middle. The cumulative math of this approach is the first domino. As Andromeda gets closer, it will grow in our night sky. In about 2 billion years, it will be a massive, glowing disk easily visible to the naked eye, much larger than the full moon. That realization would be enough to change how we see the peaceful heavens. But what happened next made the idea of a crash look surprising. We realized that when galaxies collide, they don't actually hit anything. As we move from the approach to the interaction, the tension moves from collision to distortion. Wait, before we calculate the fate of our sun during this merger, if you're finding this galactic breakdown fascinating, hit subscribe. We're decoding the cold reality of the cosmos every week. The word collision is actually a bit of a lie. NASA explains that galaxies are mostly empty space. If a star were the size of a ping-pong ball, the nearest star would be about 700 miles away. This means that when the Milky Way and Andromeda merge, the chances of two individual stars actually hitting each other are practically zero. Instead, the real drama is tidal stripping. As the two galaxies pass through each other, their gravity will pull and stretch their spiral arms into long, thin tails of gas and stars. This is the second domino. Our night sky will turn from a neat band of light into a chaotic, swirling mess of glowing ribbons. This leads to the stellar migration. While the stars won't hit each other, their orbits will be completely tossed around. NASA's computer simulations suggest that our sun will likely be kicked out into a much further orbit, perhaps 100,000 light-years away from the new center. We won't be destroyed, but we will be evicted to the suburbs of the new galaxy. While the stars are moving, the gas clouds are simultaneously mounting a massive celebration. When the giant clouds of hydrogen gas from both galaxies slam into each other, they compress. This triggers a starline event, a frantic, billion-year-long burst of new star formation. The sky will be lit up with thousands of brilliant, blue baby stars. The real drama lies not in the stars, but in the supermassive black holes. At the center of both galaxies sit monsters, Sagittarius A** and the much larger black hole at the heart of Andromeda. Focus is your greatest weapon. That decision to merge would have been enough to change the sky. But what happened next made the new stars look like a minor detail. We realized the two black holes are destined to become one. This is the peak of the truth, the birth of Milkomeda. This is the highest informational value I can give you. The collision doesn't end in destruction, it ends in a new type of galaxy. After about 6 billion years, the Milky Way and Andromeda will have finished their dance. The spiral arms will be gone. The gas will be used up. What remains will be a giant, smooth, football-shaped collection of stars known as an elliptical galaxy. NASA researchers have nicknamed this future home Milky Way. The highest informational value lies in the black hole merger. As the two galaxies become one, their central black holes will sink toward the new center. They will orbit each other, spiraling closer and closer, sending out massive ripples in spacetime called gravitational waves. When they finally merge, the energy released will be more powerful than all the stars in the galaxy combined. The climax occurs when you realize that our sun will still be alive during the start of this. In 4 billion years, the sun will be hotter and brighter, but it won't be a red giant yet. If humans, or whatever we've become, are still on Earth, the view will be staggering. They will see a sky filled with the glowing core of a second galaxy. The reality of 2026 is that galactic mergers are 80% of how the universe builds itself. NASA's Hubble and James Webb telescopes have captured snapshot versions of this happening right now in deep space. We see their antennae galaxies and the mice galaxies. All of them are previews of our own future. We aren't an exception, we are just next in line. It proves we have created a flow that has value because it is a unified version of a hidden truth. But there is a silent trap waiting at the end of this success. Everything I just showed you about the birth of Milky Way is useless unless you understand the one thing I didn't mention at the start. Most people think the collision is the end of the story. That decision to ignore the final state would have been enough to miss the point. But what happened next made everything before it look minor. We have traveled from the 68-mile-per-second approach to the tidal stripping and the final birth of the Milky Way elliptical. The resolution here is understanding that the universe is a story of constant recycling. You now have the roadmap to the collision. You know why the empty space between stars protects us. You know why our sun will be moved to the outer rim. You know why the merger of the black holes is the final, violent act of the drama. The expert status only comes after the very active work of realizing that the Milky Way we see today is just a temporary phase. Bring your expectations down to earth. Focus on the fact that these collisions are how galaxies grow and create new generations of stars, so your wonder can actually take flight. But there is one thing I did not mention at the start of this video regarding the future sky. In 2026, NASA scientists continue to project what Milky Way will look like. Because elliptical galaxies don't have much gas left to make new stars, the new galaxy will slowly turn red and dim over trillions of years. It is the ultimate senior version of a galaxy. Navigating the transition from amazed spectator to cosmic thinker is the hardest part of the journey. It requires you to stop being afraid of the collision and start being awed by the scale. If you can master this perspective, you won't just see a night sky, you'll see a work in progress. You have the data and the framework, now you just need the discipline to keep looking up as we track Andromeda's approach. Everything I just showed you is a waste of time unless you understand the one thing that truly matters. We are part of something that is literally reshaping the universe. The collision is billions of years away, but the changes to our own sun are happening much sooner. Watch this video next. It shows you the exact timeline of when the sun will expand and what it means for Earth's survival. Click it now and I'll see you there.